Hi, I'm Nadav Kaminsky.
And I am Or Dayan. Our graduation project is in the field of digital geometry processing.
Our project deals with mappings of geometric shapes from 3D to 2D space under bounds on the distortion. This might not be very clear, so let's start with some basic terms.
Geometry. A set of vertices connected to each other that constitutes a shape. We will be using shapes that are represented by many small adjacent triangles.
Parametrization. A mapping of geometry from one space to another. In our case, from 3D to the flat plane. The reason we do this is that it's often easier to process a geometry in 2D. For instance, using a texture to paint a flat shape is much easier than painting a curved shape in 3D.
Distortion. The process of parametrization will inevitably distort the geometry. That is, the area and the angles of some triangles will change. Bounded distortion means that we want a parametrization that induces a distortion not greater than a certain user-defined amount.
So let's review the project's title once again. Bounded Distortion Parametrization from 3D to 2D. Sounds simple, right? Well, it isn't. Why not?
First off, this problem is hard to solve computationally due to many restrictions on the solution. To overcome this obstacle, we will solve a sequence of easier problems approximating the original problem. Moreover, most shapes have to be cut before they can be properly placed on the plane. This cut can be performed in many different ways. Each induces a different distortion. We should find a cut that meets our needs.
So what does the algorithm actually do? It receives as input a geometry in 3D and a target bound. It cuts the shape, computes the parametrization, and renders the flattened shape. Finally, we can assess the quality of the results by visualizing the distortion. Here are some examples of the results we obtained.
Thanks for listening.